Hey ladies and gentlemen, this video is about inequalities in one triangle. So I think that the best way to explain this topic would be to do a PowerPoint just like normal. Even though I'm not writing in my actual notebook right now, you guys should continue to take notes in your notebook. I think the colors are really helpful here as well. So basically the side angle relationships in one triangle. This explains that wherever is the longest side is going to always be across from the largest angle. And wherever is the shortest side is going to always be across from the smallest angle. So an easy way to remember that is to kind of just draw these little arrows when you're trying to figure out the order of the sides or the order of the angles. Here are two theorems that you don't really need to know what the name of the theorem is, but you do need to understand it. So I would pause the video for a moment and jot down these two theorems into your notebook and then draw these pictures as well. And when you're done writing them down, resume the video so we could go through it. And so essentially, just what we were explaining, that the largest angle is across from the largest side, this works when you're comparing sides as well. So for example, I noticed that, 5 is bigger than 3. So since 5 is greater than 3, I know that the angle across from that side of 5, which is A, has to be bigger than the angle across from 3. And that makes sense because the sides would have the same type of relationship as the angles across from them, or opposite. Okay? The same thing works as, the opposite. If you know the angles, then you know a relationship with the sides. So if one angle of a triangle is larger than another angle, the side opposite of the larger angle is also larger than the side opposite of the smaller angle. So again, you look at these two angles. Okay, 60 is bigger, so you could think of it like this. 60 is greater than 40. So therefore, this side opposite of 60, which is EF has to be bigger than the side opposite of the 40, which is DF. And so this is your conclusion. Okay, here's two examples in which the directions are asking you to write the measurements of the triangles in order from least to greatest. So first of all, I want to clarify what this word measurements means. So we've got two types of measurements for every triangle. We have angles and we have sides. Oops, we have sides. Okay, so basically for each one of these questions, you are going to be having 6 pieces of information because there's 3 angles and 3 sides. Okay? Okay, so when you are given, let's say you're given angles on this, it's pretty easy to put the angles in order from least to greatest, because 35, then 45, then 100. So you would want to name your angles. So we would say measure of angle G, whoops, lowercase, angle G is less than, because we're doing least to greatest, so the measure of angle G is less than the measure of angle H, which is less than the measure of angle J. So this is how you would order the angles from least to greatest, but don't forget we also have sides, so we need to now look across from those angles to figure out what is the smallest side. So G is the smallest angle, which means across from it is going to be the smallest side. So that's going to be HJ. And then was angle H was next, so across from that is going to be, this is going to be our medium side. And then lastly, across from the 100 is going to be the largest side. And so to write our measurements from least to greatest for our sides, we have HJ, which is less than JG, which is less than HG. See if you can go ahead and try example B. This time they give you the sides, so I would start by ordering the sides from least to greatest and then look across from the sides to see which angles are going to be least to greatest. The next inequality in one triangle is the exterior angle inequality. And basically, this is very similar to the exterior angle theorem, which we've already learned that angle 1 is going to be equal to A plus B. So therefore, if angle 1 is equal to the sum of the two remote interior angles, therefore it has to be greater than each individual angle. Okay, here's an example of a word problem where you might get on a quiz or a test or your midterm that asks you to explain how you know your answer is right. So you've got Jack and Jill are both located somewhere away from the park. We want to know who is further from the park, Jack or Jill, and then explain how you arrived at your answer using one of the theorems we just talked about. So the first thing that I notice is that Jack has no angle measure. So I would pause the video and figure out what angle measure has to be right here for this part of the triangle. Okay, so I know that this angle has to be 50 degrees because all three angles have to be total to 180 degrees. So now that we know this, we can start to compare the side lengths of our triangle. And so I would start by looking at the smallest angle, so 50 across from that. This is going to be the smallest side. And then, let me grab a different color here, 58. So this is going to be the medium side. And then lastly, 72 is going to be the largest side. What happened to my... This is my smallest. Okay, so now, even though we have no clue what the actual side lengths are, we can compare least to greatest to figure out who is further from the park. So, this is the park right here. I want to know who's further away, Jill or Jack. Now, I notice that Jill is on the smallest side and Jack's on the longest side. So I know that Jack is furthest away from the park because, and here's where you're going to explain, the segment that connects Jack to the park is opposite of the largest angle. And that's an inequality in one triangle. If you are looking for a written explanation to put into your notebook, here's one for you. You can pause the video and jot that down. Basically, is exactly what I summarized just a moment ago. For this next part of the video, I'm referring back to the activity that we did in class, where you had to break spaghetti into 3 pieces and try to form a triangle, and then break spaghetti into 3 pieces so that it's impossible to form a triangle. So as I'm explaining the next theorem, just keep this activity in the back of your mind. Okay, so this is the triangle inequality theorem. And essentially what it says is that any two sides of a triangle, when added, has to be bigger than the third side. And so when you were going through that spaghetti activity, hopefully you noticed some of the triangles that were impossible to be closed. They couldn't be closed because the sum of two sides was not bigger than the third. And so if that happens, it's actually impossible to have a triangle. So I would go ahead and jot this down. Make sure that you get all 3 of these examples because all 3 of them are true. So you need to know the triangle inequality theorem in order to find possible side lengths for a third missing side. So let's start off with just a basic example, nothing too challenging yet. I would write down the whole word problem in your notes or draw a picture to supplement if you need to. So the question is, a triangle has one side of 10 centimeters and another side of 14 centimeters. Describe the possible lengths of the third side. And so there's more than one possible side length that will satisfy the triangle inequality. And so what we're looking for basically is a range of numbers. So there's 2 possibilities. Either the length of 14 could be the largest side or the missing side could be the largest side. So let's pretend that the 14 centimeters is the longest side. Then we can set up this inequality right here. That says the smallest side plus the side that's 10. These 2 sides added together have to be bigger than the third side, which is 14. and you know by subtracting 10 from both sides we'd get x is bigger than 4. Okay, now again, that was if 14 was the biggest side. 14 doesn't have to be the biggest side because our missing side might be bigger than 14. So the second possibility is that 10 and 14 are the medium and small sides. Those two sides together have to be greater than my missing side. Now we add 10 and 14 to get 24. 24 is bigger than x, which means that this is basically the limit. So the third missing side has to be between 4 and 24 centimeters. And so here's a sentence to kind of sum that up. The length of the third side must be greater than 4 centimeters and less than 24 centimeters. You could also write this as a compound inequality if you prefer, rather than writing a sentence, to basically summarize your answer like this. 4 is less than x, which is less than 24. So here are some posing questions that I will leave you with. If you really understood the concepts in this video, you should be able to answer these before you come back to class tomorrow. So the first one is, what is the relationship between sides and angles in one triangle? Second question is, what is the triangle inequality and how can it be used to solve problems?